So the next demo involves the University of Buffalo, and to kick it off, we'll bring in the principal investigator from Zoom. He's coming in on Zoom because he's actually part of the demo. So he'll be him and his lab are going to be driving one of the vehicles in a simulation remotely. It looks like we have him here. I want to check the audio real quick. This is Dr. Huh from the University of Buffalo.
Hello, everyone. Thank you, Derek. My name is Professor Chaozhe He. I'm assistant professor with University of Buffalo. Together with a team of researchers, we today present a demonstration on our work with Mcity on multi-agent, multi-modality simulation and testing. So first, let me introduce the team. It includes a couple faculty, including myself, Professor Austin Angulo, Professor Irina Benedict, who is actually in the simulator view on the pedestrian, and Dr. Kevin Hume. And we have a group of capable students, Mr. Ye Wang, Mr. Vivek Vishman, and Mr. Sen Jiang, who has collectively working out this simulation environment, mixed reality environment with Mcity. So what are we exactly trying to solve here? So the research question we are really interested in is how human and AV actually interact. And here we mean human as a road user, not the one actually inside the AV necessarily, different from the previous demo, but those road users, including human drivers, including pedestrians, cyclists, vulnerable road users. How do they perceive and react to AV? Now, the challenge that we are facing is that we can test this, but how can we really repetitively test these AV behaviors influence, especially in safe critical cases with human? It's hard to really establish this, even if we have a designated facility, that this interaction in a safe manner. And particularly if you talk about safety critical cases, how do you repeatedly evaluate this to actually get into safety critical cases without actually being very safety critical? So this brings us together with Mcity to see the capability we have actually complement very well with each other. Now, to give a little bit more on these scenarios that we're testing, humans AV is gonna be interacting with humans. They need to do this safely. So we're talking about here. I show on the top of my head, basically scenarios with human driver and autonomous vehicle, very highly interactive scenarios like unsignaled intersection or merging zone. There are a lot of interplay between AV and human in these cases. How do humans perceive and react to AV is the question that we try to answer. On the flip side, at UB, we are having capability to bring road users like cyclists or pedestrian into this. We are also interested in how AV's behavior would influence humans' behavior, or at least how human road user would react or perceive AV's behavior in safety critical cases. So what we are able to do, or what we were able to do before we talked to Mcity, is what I'm showing here to my left. We have a bunch of simulators available here that does simulated based human subject study. We have full scale human vehicle simulators, different level of reality. We can even have the vehicle shaking with pistons, or at the very least, some kind of latitude or longitude motion to mimic the vehicle motion. We have very high tech, state-of-the-art pedestrian or bicycle simulators. These allows us to have the road user, human driver, pedestrian, cyclist to have an immersed experience when they are interacting with vehicle that is being simulated. But what we don't have is a very well-equipped test vehicle, plus more importantly, purposely built test track. And that's exactly what Mcity has. They have the state-of-the-art, Mcity has the state-of-the-art AV testing capability, but not necessarily with high fidelity where road user could bring in. So that's where we come together, try to combine both of our capability to actually allow human perceiving and evaluating humans' perception and reaction with respect to AV in a mixed reality environment. So this is our effort that we have done with Michigan. So basically, we have in here behind me the simulators that users can join remotely, interact with Mcity's actual vehicle on the actual test track. Now, this is enabled by the Mcity OS, or the whole infrastructure introduced at the beginning by Professor Henry Liu, about this capability being built up. And what this actually allows is we're testing interactive behavior scenarios, potentially safe critical ones, even prompt to accident, without actually getting into an accident. And because of the way we are able to bring in simulator is very high fidelity, human has the first immersed view. This will make sure the fidelity is there. Now, in the demonstration you will see today, let me see. In the demonstration you will see today, we will showcase the interaction that could happen enabled by this setup between the AV and two potential road users. One is the human-driven vehicle, which is behind me. The other one is right next door, the pedestrian, now operated by Professor Irina Benedict, that will be crossing as if they are on the Mcity road. So both of these parties will be remotely present in Mcity. They will see the actual Lincoln's behavior in their respective view, but the Lincoln will also see their behavior, and you will see the interaction happen seamlessly. And the route we will be taken is not far from you to the tent. It's between that Main Street and the Wolverine Avenue, as highlighted on the map. So the benefit of having this is what we see a very good extension to the current Mcity 2.0, because we bring in the road user's perspective to AV testing. That allows us to evaluate safety critical scenarios with really a first person view. And what's nice about simulation is that this can address the curse of rarity in observed safety critical events, because we don't need to set up these scenarios in real life in a very structured environment. We can repetitively having simulated part of the player to repeatedly test the same scenario. But we still have a percent of the real AV. So we actually have the whole benefit of AV's high fidelity model in terms of vehicle response, in terms of planning and control algorithm, actually in the simulator. So as someone who are interested in humans' behavior and reaction, we don't need to deal with this high fidelity of AV's capability building. And what we hope at the end to show through this is that this allows any road user, researchers who are interested in understand humans' perspective can call in the same way without really having everything high fidelity. Even if they just have a joystick or have a keyboard, they can still use the infrastructure to actually test humans' behavior to some extent. So the next step, or the ongoing work entering the fall and the last year, is we are actually testing having human subject into the loop, and then testing AV's behavior, human subject's behavior to AV's behavior. For example, one of the active work that my team is working on is to see in these highly interactive scenarios whether AV's behavior is actually influencing humans' behavior if we actually tune our AV behavior differently, and whether the human would evaluate, consider it safer, consider it persuasive, consider it polite, and so on. So this is one of the ongoing research from my team. The whole team has capability also interested in other road users, pedestrian and cyclists and so on. We will be conducting similar study along this route. So I think with that, I would like to conclude my introduction and turn the floor to the actual demonstration.
Okay, thank you, Dr. He. And same gig as before. I'm going to tell you what's going to happen. I'm going to tell you what's happening as it's happening, and then we'll have questions about what just happened. Okay, so live from Buffalo to Ann Arbor, we're going to do a little bit of remote distributed testing here with mixed reality. So today we're going to be displaying the following features, Mcity 2.0. We're going to have distributed testing, where we have many remote actors interacting safely. So you'll see a pedestrian simulator and a vehicle simulator. Both of them will be interacting with our real vehicle, which is being driven autonomously. And our vehicle will be aware of the other vehicles, and they will be aware of our vehicle. And they can interact in a completely safe manner. Yeah, I think that's pretty much covered the third one as well. So the actors in this scene are real MKZ out on the facility again. There will be a person, Dr. Irina Benedict, in the pedestrian simulator you see there. She's the image on the left. There will be a real person, that's Vivek, driving a vehicle simulator in Buffalo, New York. Both of those people will be in Buffalo, New York. Vivek is a master's student at the University of Buffalo. You can see him in the middle screen there, and the top right is our vehicle. And then another actor in this is our Mcity Carla digital twin. So all of this will be happening in the Mcity Carla digital twin. There'll be a simulation here. There'll be a simulation in Buffalo. And the actors in Buffalo will be getting our information from the real vehicle. It'll be injected into our simulation as well. And all of their reactions to and whatever they're doing, their actions and their positions and kinematic information will be shared back with the simulation running here and with the vehicle as well. So again, a couple of slides with a bird's eye view of the scenario. In screen one there, our vehicle is the white one at the top. The little yellow pedestrian token, that is going to be Dr. Benedict in the pedestrian simulator. And then the red vehicle at the bottom, that is Vivek in the vehicle simulator. So the red and the yellow are both coming from Buffalo, New York. The white is coming from our facility, and you can see the vehicle right out here, right behind us. So under normal circumstances, without our scenario, our vehicle will be attempting a left-hand turn at the intersection of Main and Wolverine here. So coming south, our vehicle will get into the left-hand turn lane and then want to make a left-hand turn. Except that Dr. Benedict is going to get in the way with the pedestrian simulator. So that will get in the path of the autonomous vehicle. And I'm going to grab my microphone here as I step away here. She will walk out in and then do one of those things where you turn and you see the vehicle and you kind of think left or right, which way do I go? And then she's going to continue on to clear the intersection. Once the intersection is clear, our autonomous vehicle will move on and have its second interruption. This time Vivek will move into the path, and there you see in the image labeled number 3 there is the simulation of the vehicle simulator from the University of Buffalo in red, getting in the way of our real vehicle here. And then once that vehicle clears the intersection, our vehicle will be free to move on. So the whole point in doing this is we have real interactions with a real vehicle, but in a completely safe manner, and to show off our distributed simulation capabilities here. So now for the feeds. So these are arranged just like you'll see them with our familiar local and remote. On the remote side, you're going to get the big view shows our infrastructure camera. So this is a real 4K camera looking at the scene, and you'll see our vehicle out there. And that vehicle will make the path I just showed you from the bird's eye view. In the bottom left of that screen is the AutoWare view. It'll be oriented just like the intersection. And you'll see that green and the red path, just like I showed you from the bird's eye view in that, but it'll be live. On the right screen, remote, will all be from Buffalo, New York. In the top left of the right screen is Vivek driving that vehicle simulator. In the top right is Dr. Benedict walking in the pedestrian simulator. And then in the bottom left will be a view from the simulation world. So that view from the simulation world is one of those distributed simulations showing all the actors. Right from our infrastructure view, you're not going to see any other actors on the scene because they're all in simulation coming from the simulators from Buffalo, New York. And in the bottom right is a camera that is mounted directly behind the pedestrian in the virtual world. So when Dr. Benedict walks across the intersection and turns, that camera will always be behind her head and showing you the view that she would have over her shoulder of the vehicle, our our real vehicle rendered in simulation. So hopefully that all makes sense. And I'm looking up at my crew now to see if we are ready to go. We are ready to go. Excellent. So I'm going to take the microphone now, and I will narrate this from the floor because I can't see both unless I'm down here. So again, we have all the views that I mentioned for you. So as soon as that vehicle in the top left begins moving, that means our scenario is active. So Raj is our safety driver here. He's out on the facility and he's communicating with everybody at the University of Buffalo. You see Vivek climbing into the simulator there. And any moment now, they'll be doing the countdown to begin the simulation. There's Dr. Benedict waving. Okay, the vehicle is underway. So the vehicle will try to get in that left-hand lane, but it's being blocked by the simulated pedestrian, or the pedestrian from the simulator, pardon me. And now that she has cleared that intersection, our white vehicle is able to progress into the intersection where it is blocked anew by the vehicle in the simulation from the simulator at the University of Buffalo. Now Vivek, driving that vehicle, decides to clear the intersection, and our vehicle is free to move through again. So again, a lot of moving parts here, a lot of things to watch, so we're going to run it again for you. And Raj will go ahead and reset. And once he does that, I will re-narrate, and then we'll move to Q&A. Again, the second time through, I highly recommend you try to watch something else just to get a better picture of what's going on. Lots of moving parts here. But the basics are we have two people in simulators in the University of Buffalo interacting with our real vehicle out on the facility being driven by AutoWare. And AutoWare is just doing its thing. It's trying to navigate, and when there's an obstacle in the way, it's stopping. Okay, we are very close to reset. And as soon as Raj is ready, I'll let my team know that we're good to go here. So as soon as they're ready to go, they're going to go ahead and start the scenario again. You'll either see the vehicle move in the top left, or you'll see Dr. Irina Benedict walk into the crosswalk. There we go. So we're starting again. She gets in the way. She turns and looks at the vehicle. The vehicle is moving, trying to get into that left-hand turn lane. She then clears the intersection, or the crosswalk, I should say. Now our vehicle is free to move again, moves into the left-hand turn lane. And this time, Vivek, the master's student from the University of Buffalo, is blocking the AutoWare path, and the AutoWare vehicle stops again. Vivek decides to clear the intersection, and our vehicle, the real vehicle, is free to continue. There you have it. Do we want to do it one more time? I guess the crew is eager to do it again, so we can do it one more time if we want to. Yeah, let's do it one more time. Which means I have to kill about 30 seconds here as we do a reset. Anybody know any good jokes? Yeah, we can do some questions right now, actually, while we're redoing this. Are there anybody who we have one in the back right there?
Yeah, thank you. So this demo is different. My question is about the testing infrastructure capability. So, there are two demos, both different, both quite complex, yet it looks like you're using the same Lincoln MKZ vehicle test platform, and somehow is that correct? And have you switched over? And can you talk about just the flexibility of using the same vehicle? I mean, it seems like you just dynamically switched to a completely different test, in the course of this demonstration. Can you speak to that?
Sure thing. We are using the same vehicle. These vehicles are generic use vehicles. It's normally a little bit more challenging when we have to switch from one research team to another research team. But we've kind of found a sweet spot over the past 5 or 6 years. And I described it earlier with the two computers in the trunk. We have another vehicle that is kitted out in almost exactly the same way. We have one vehicle which is doing the robotic operating system, the publication, subscription model of sharing information. That's fairly generic and fairly, common among a lot of research usages. And the other computer is doing AutoWare, so doing the control. Where things can get different is if there's anything on the vehicle that needs to be different. For this example here, it's just AutoWare trying to run a path, right? And then we're feeding the positions of the vehicles into the simulation so that AutoWare can quote unquote see them, right? But there's nothing really special on the vehicle beyond our generic base kit of our vehicles. So hopefully that answers your question. There are definitely other research needs that are a little bit more challenging when it comes to compute and software running on the vehicle. Any other questions? I think I missed my narration there, but that's probably better for you guys not to hear that again. So, all right, I think I will. Sorry? We have a question from the field about latencies. The latencies, actually, I don't know the answer to this one because we're coming from the University of Buffalo. I suspect they're slightly different than when both our actors were here. I might have to table that question and get back to you, Greg. Any other questions? Okay. Chelsea?
Hey, Chaozhou here. So I want to comment a little bit on the latency. Okay. So Derek is right. There are complications in the sense that there is both delay contributed by our simulator and also this communication. What we can say is that the communication itself is definitely less than 100 milliseconds. And for the simulator, it's actually 40 to 50 milliseconds most of the time. So one direction. The simulator side, we have way to mitigate the latency for the view that the test user, with pedestrian, cyclist, or human driver, how they see this environment. That's a different latency. So these are two separate latency, but combined together, we are experiencing 100 millisecond or less latency so far. If we have more agents calling in, then this may be changing, but within the current development that we do, up to 2, 3, it seems to be very manageable.
How about a question on next steps, right? Other simulation modes, other simulation controllable actors on our side?
Thank you very much, Greg. So I can comment on the simulator from UB side. In today's demonstration, we show two particular simulator. One is this one behind me, I think the more basic version of the driver simulator. We have a full-scale simulator which has a piston below and the 360 green. We are working on bringing that with a better immersive view for human driver. And we also have different agent capability for cyclists and pedestrian, and particularly for them, we are looking to having the AR the goggle in place so they have an even more immersed view. Now, from research perspective, the next step is really utilizing this capability to access people's evaluation on whether they feel safe about AV's behavior, whether they have been influenced by AV's behavior from both all these road users. So these are ongoing research by our research team. So that's a comment, I think, from UB side.
Thank you, Dr. He, and thanks for those questions, Greg Stevens. At this point, I think I'm going to hand the podium right back off to Greg here, and he's going to introduce our next demo.